Welcome, everyone. I'm Joe Gillard, editor of ISE Magazine. This is Let's Talk Telecom, and today I'm talking to Omid Tahernia, who is the CEO of Eridan, the developer of what they call the world's smallest, lightest, and most efficient 5G radio. Thank you so much for being here, Omid.
Thank you, Joe. Good to be with you.
So maybe we can start out. You can tell me what's different about Eridan's radio technology when compared to traditional 4G or 5G deployments.
It's a good question, Joe. Good to meet you, by the way. You know, there are so many attributes about our radio that are different that sometimes I have to pause and think about how do I want to answer that question. But ultimately, is about our radio architecture is completely different. So the way I would peel the onion a little bit is I would say at the highest level is direct polar modulation. It is a completely digital radio. So there is an element of switching that we bring into the architecture. So I would say direct polar and switching architecture that ultimately builds an all-digital radio. That enables a number of attributes that then kind of outflows as a result. Now, we didn't invent polar modulation. However, we're the first company in the world that has realized and implemented it. And I would say that 12, 13 years of work has gone into the company into really bringing this technology to bear in terms of implementation and realization. And now we're at a point where we're actually in the process of ramping our first product, which is a 2x2 RU. It's an outdoor unit that I was at MWC, and some people thought it was an indoor unit because it's so small and so lightweight, and we'll kind of talk about that a little bit. So there's a good bit of technology and implementation that's gone into it. Now, the next question that I get often is, what chipset, off-the-shelf chipsets are you using? Well, we're not. We're using our own in-house developed custom silicon on both the power stages, where we use gallium nitride, as well as on the modulator, which happens to be a mixed mode SoC that happens to be CMOS silicon on insulator technology. We also have an extension of within our platform, we have an FPGA. We have a partnership in this particular case with AMD/Xilinx. By the way, that product family that we use is actually what I created at Xilinx, called Zinc family of processors. So that's part of our platform. And we also have a partnership with ADI on the receiver side. So if you look at under the hood, you will basically see our transmit architecture, which is implemented in our chipsets, plus software. We have the FPGA on the front hull and the interface to the CUDU, and then we have the receiver architecture. As we go forward, there will be more integration that we're thinking about, more and more of these elements. We don't have to integrate things just on the whim, but we will do it as it adds value at the platform level. I would say primarily in terms of power consumption.
Okay.
Because the FPGA today, at least the configuration that we use, probably represents about 15% of our power consumption, which is fascinating, and so on. So there are opportunities. I guess that's kind of a forward-looking thing. So we do a good bit of software development that runs on our modulator. It's a RISC-based architecture on the compute side. And then we use the FPGA for some of the heavy lifting as well as the interface. So what all this yields is a very low power consumption radio. We consume sub 40 watts. A typical RU would be in the 150, 160 watts. If I'm being conservative, kind of in that range. So we're, and we see, again, as I mentioned, the FPGA alone is about 15%. So we know how to reduce the power consumption even further. And we think this is doable to within, let's say a sub 30 watt radio going forward. So that's, which is pretty phenomenal. Um, so that's one aspect of sort of our size and weight. The other aspect is just the topology of our power stages. We don't use linear amplifiers, the traditional power PAs, if you will. We don't use algorithms like digital pre-distortion, DPD, and all that, because fundamentally our transmitter architecture is very different. So there are further opportunities in sort of enhancing that. Our current product delivers 40 megahertz bandwidth, and coupled with the grant that we received from Department of Commerce at the end of last year, which is a $37 million grant. It's a 2-year grant as part of the CHIPS Act. And we basically utilize that to build our next generation radio, which is 100 megahertz bandwidth, and basically an evolution of the content or the chipset inside. And we expect that to have at the end of this year, beginning of next year, is introducing that to market, and that'll be a 4x4. That'll be a 4x4 RU. So while our go-to-market product is an RU, obviously the technology is deeply embedded in silicon, but fundamentally we're gonna take advantage of the dynamics that we see in the marketplace, with Open RAN, AI RAN, which really disrupts and breaks down the elements of the system. So we obviously have partnerships with many in the area of CUDU and integration, but RU is becoming, yes, there are applications where everything is integrated in one box, but really that disruption is creating an opportunity for us to basically position an innovative radio unit as part of that deployment. One other thing before I forget is that because of reduction in complexity of the radio unit, the weight of the unit is 1/5 of what you would traditionally see. So we're 2 kilograms plus compared to about 10 kilograms with a traditional RU. So I joined the company in January. My background, by the way, started at Motorola many moons ago, Joe.
Oh.
You got a little bit of gray hair, but I think I have a ton more. I do. So I've been around a while. I started my career as an RF engineer at Motorola and wireless, actually, and built products and so on. And then later, halfway through my career, I transitioned towards semiconductors. So when I saw this opportunity back in Q4 of last year, and I talked to the chairman of the company, Atik Raza, it was just phenomenal opportunity in terms of my skill set bringing to the company, but also looking at sort of where the company is around and appreciating sort of what the innovation is on the radio side. I really wanted to be a part of this. And so I joined officially beginning of the year, January 2nd to be exact. And I can tell you that there is nothing that I've seen here that suggests that I'm more excited than the first day I joined. So that's kind of a umbrella of who we are, how we differentiate. One of the other things that's very unique, and it's actually a bit of a challenge for us in explaining. So we have in our 2x2, it's basically a 1/4 watt per channel, 1/2 watt radio. And when we present that to customers, they ask me, when are you going to have your 5-watt radio? And I said, well, we don't need one of those. If I can give you, just put that aside for a second. If I can give you higher throughput to the edge of the cell, as opposed to a traditional RU that data rate starts coming down as soon as you start moving away from the cell. What do you care if the output is 1 watt or 2 watts or 5 watts or 10 watts? And that's I've heard comments from unbelievable to mind-bending to all kinds of things. And I'm not saying that for a fact. I've literally heard those. And it's not until they come and actually see our radio on the tower on our roof, second floor of our building here, that they see what we're talking about. So we can easily, in the CBRS band, we're sort of in the 3.6 gig range, and they can see the throughput they get and how that does not come down is actually just because our EVM or our constellation of the QAM signal is so clean compared to a traditional radio. So the EVM, error vector magnitude percentage, we can be in the range of 0.5%, definitely less than 1%, depending on frequency. So it varies, but it's very clear. So the user equipment, could be a cell phone and others, can see our transmit signal. And at some point, you would be limited by sort of how far the device can communicate back. So that's the other thing that's quite different about our radio is that we essentially compete. Our half-watt 2x2 radio competes with a 5 watt per channel 2x2 or 4x4 radio,
Mhm.
which is quite until you see it and until you see our EVM data set, and there are published results by Keysight Technology, who's a pretty close partner of ours. Basically, they told us our signal is so clean that they're starting to hit the bottom, the noise floor of the measuring equipment. And that's where they're interested in our relationship because they think they have to do better, as kind of they look at innovations in radio going forward. So that's the other aspect of our radio technology is very unique. That has benefits. It has lots of benefits in terms of, kind of, I would say RF pollution.
Mhm.
You don't have to blast your way to something, right? It's like a directional microphone versus,
Right.
having to scream, right? That's kind of what radios do.
Interesting.
I mean, you just crank up the power, and that creates a lot of, reflection effects and other aspects of the RF environment. That's not good. So we can demonstrate that. We're in the process of ramping. We're building our 100 megahertz platform. That will be a band 77 focused. And then one last comment I would make is that our radio architecture is unique in another sense is, as I mentioned, it's an all digital radio. So the radio can support 600 megahertz to 4.2 gigahertz. And the way we band limit this thing or band, deliver is we actually have an all passive filter that goes on top of our radio. So once we have these filters for the various things, then we can basically drop it onto the RF board, if you will. And we don't have all this complicated tuning algorithms that you really have to have with a PA, linear amplifier, and everything is kind of hardwired, if you will. Because if you're building a certain band, you have to tune it a certain way. All the components are in line with the PA input and output, and you basically build that in the factory. Now, that RF board is tricky, right? We know that. So isolating sort of the band side of it from the radio side of it is quite an accomplishment, I think. I was frankly very
Yeah.
excited about that aspect of it. So that's
Yeah.
the other thing. So going forward, we have other bands that we're going to deliver even on our 2x2. But band 77 will be the first focus. 77, 78 will be the focus of the 4x4, which is 100% in line with the NTIA grant that we have.
Cool.
We have partners as part of that. We are the prime in that grant. We have Verizon, we have CityMesh in Europe, Verizon in the US, Rakuten in Japan as MNO partners.
Mhm.
And then we have on the integration side, we have people like Capgemini and Radisys and others. So it's a whole ecosystem, part of that grant. We're the prime, and we basically have sub primes, if you will, as part of that.
Wow. That's
We're
cool.
Yeah,
Yeah. Congrats on the new role. I mean, how nice and poetic that they have a Motorola pioneer here working on this new, who was the original pioneer in that space, and that's super cool. And it sounds like congrats on the grant too. It's a great opportunity. And so I was hoping you could tell me a little bit about a lot of our audiences, service providers and telcos, and maybe tell me with examples if you have them about how it can be integrated into or added to 5G deployment strategies that telcos and service providers are already using.
yeah, very good question. So this is one aspect of sort of the enterprise, building the enterprise that we've been working on over the past three plus months. And we have a good vision and a strategy, and we've bounced that off of sort of our ecosystem partners. So our go-to-market is not going to be, throw an RU over the wall. We're going to work with systems integrators. And there are some OEMs that actually, integrate themselves and maybe buy some components, maybe buy a Radisys stack or a Capgemini stack. But ultimately, and we have targeted customers that we're starting to work with, but we basically the first step is to integrate our RU with a variety of CUDUs, and we're way underway on that front. Our focus from an application perspective initially is going to be private 5G. Lots of applications, rural applications, industrial warehouse applications, hospitals, really even defense as a segment, in terms of kind of deployment, quick deployment, packing up and going somewhere else, that kind of application. So we're focused on private 5G. There is an opportunity with MNOs on offloading for user experience as well as bandwidth and capacity. There are some greenfield opportunities as well as perhaps some brownfield opportunities, but those will come. We know that those will take a bit longer. Just working with MNOs just takes a bit longer. We have a targeted OEM base. By the way, Verizon is as an investor in the company, so we're pretty closely tied with them strategically and alike. So that's our go-to-market. Application-wise, we're going to focus on private 5G. We envision providing more and more software, some value-add software elements tied to the radio, and then we provide services as part of our bundle of hardware and software. So that's our go-to-market strategy.
Excellent. If can you talk a little bit more about the rural applications? Is there is there an element that can help with BEAD deployments, or are there rural government funded projects or just rural deployments in general? How does it factor in? How does it help those deployments, that connectivity?
So one, ease of deployment, because you can put the entire thing on your backpack, really a single person installation. I have one of my application engineers and really someone who's working together with the balance of the team that's focused on testing, field testing, and so on. We're about to go to kind of a desert in the Nevada area to do some field testing. So the whole process of installation deployment is pretty rapid. Like I said, many people think it's almost looks like a Wi-Fi access point.
Right.
Which is a bit of a challenge when you're talking to someone who wants an outdoor unit. But nevertheless, I think the installation ease, as well as power consumption. So, now you have an opportunity, you have a radio that's drawing 40 watts, so you can truly use solar panels, solar panels for power, for instance. So I would say is ease of deployment, installation, power consumption, and ability to tap into other sources of energy would be one. We think there's a huge opportunity in these areas. Some of these locations, by the way, we're starting to go to do some field testing. Are places where they've actually said, please leave your radio. We'd like to kind of provide sort of a 5G access point to, the neighborhood or, vineyards and so on. So we actually love that because then we can kind of get some field data and, maturity data and all that stuff. So that's a natural fit, in terms of agriculture, in terms of rural, even consumer connectivity, but plenty of opportunity there. That's I would say, a very natural area.
Well, thank you. Yeah, thanks for explaining that. The other focus here, of course, is private 5G, as you mentioned. I know that there's some challenge with the complexity of private 5G that businesses are faced with when they're considering setting up these networks. So maybe you could tell me about Eridan's role in simplifying private 5G, or just talk about private 5G in general.
So let me talk because one of the first questions I asked with some of the folks that I brought in from the industry, including an ex-executive at Nokia almost 30 years, was because I've been hearing 5G, private 5G for a while.
Mhm.
And really, I didn't realize there were some obstacles that have recently been sort of, I would say, shattered in some respect, but if you don't want to be to that extent, I would say has changed, and the barriers have been lowered. One is the fact that there is 5G SA, 5G standalone. Even my iPhone has an option that I can turn on to get on a 5G SA.
Hmm.
But when 5G launched and all these private application kind of concepts, you needed an LTE as the backbone, 4G network as the backbone to launch these kind of 5G applications. And of course, you need a Nokia, you need an Ericsson, and you need an MNO to come and do this, right? Very pricey, very expensive. The business opportunity is not very large. They're not really interested. So I would say that was a big hurdle.
Hmm.
The other one is the open interface, the ORAN, AI RAN, Cloud RAN. All these things, really what that all that means is that basically the value chain is being disrupted to the point where now it's not at the control of proprietary architectures that Nokia's or Ericsson's and others may have had, or Samsung and others, not picking on anybody, but that just kind of had opened up the market, and so I'd say those are the two big enablers. Now we bring in other elements of performance, obviously power consumption, ease of deployment to that. So we think 5G, when we look at the market and we see the opportunity and we see some of the early and signs of uh, those applications starting to grow, frankly, I think we have a bit of a challenge on ramping quickly and getting to market. So I think it's finally happening.
Yeah.
And I'm hoping that we can be a part of that as an enabler.
Excellent. And then you talked a little bit about the Open RAN. Is there anything else you want to expand on that, or your projections for how its position in the market in the future, and how you'll be a part of it?
Yeah, I mean I mean that's at the core of our strategy. We just recently joined NVIDIA's started commenced AI RAN. So we truly believe that the CUDU is being commoditized in some respect, and depending on sort of the application, it can really all get integrated into the cloud. So at the end of the day, you have a radio and you have a connection to the cloud, if you will. So we're a firm believer in that. We have no aspiration of having a proprietary interface to do that. We have the latest and greatest ORAN that's been integrated in our interoperability testing.
Thank you. Yeah. Well, before we part, I want to give you an opportunity if you'd like to say anything else to our audience.
No, I think, well, when I first came and we were looking for a tagline for MWC, and I was talking to my newly acquired head of marketing and sales, whom I worked with at Motorola. Used to work at Vodafone,
Oh.
Motorola, and lots of other places. Um, I said, I was telling him, I said, Rick, this is the first innovation I've seen in radio, RF radio, since I began my career many moons ago at Motorola.
Wow.
And so he wanted me to elaborate, and which of course, we discussed at length, and we came up with this tagline that says the 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 biggest innovation in radio since the radio. And that caught some attention, like, oh, what is that about? But really, that's how I feel about it. I wasn't trying to practice on the tagline. That's how I felt when I looked at it. And I said, everything has been going towards AI and compute and multi-core and GPUs, and it's all been on the sort of the processing compute side. And I'm not saying not rightfully so, but a lot of the stuff on the RF side, if you look at what's inside an iPhone, all the different bands they have to cover, all the different PAs they have DPD, CF, all this complex. I'm actually shocked at how they can integrate all that.
Yeah.
Pretty high cost, by the way,
Yeah.
into a radio like that. So I truly believe that polar modulation coupled with a digital RF front end is really the first innovation since the radio.
Awesome. Well, you're welcome back anytime. We can catch up, later and see how things are going. But I just want to say thank you, Omid, for sharing all this information with us.